All right, today we are diving deep into something that happens every single time you go online. We're going to map out the hidden journey your data takes by looking at the data flow through the OSI model, which is basically the invisible rulebook of the internet.
I mean, really think about it for a second. You type in your info, you click that login button, and poof, you're in. But what actually happens in that tiny fraction of a second? It's a whole lot more complex and, frankly, more amazing than you might think.
So that's what we're going to do. We're going to follow that one single click. We'll treat it like a tiny digital traveler and trace its path, from the moment it leaves your screen all the way across the wild internet to its destination, and then all the way back.
And that right there is the key. Your login info, your email, whatever it is, it doesn't travel in one big piece. It gets broken down and neatly packaged into something called a data packet. You can think of this packet as the hero of our story today. Now, this journey our packet takes isn't just random chaos. It's not just floating around hoping to find the right server. Nope. Our data packet has a map, a very precise set of directions it has to follow. And that map is called the OSI model. The OSI model, that stands for Open Systems Interconnection Model, is essentially the official rulebook for the internet. It takes the huge, complicated job of network communication and breaks it down into 7 manageable layers. Each layer has a very specific job to do, and they all work together to make sure your data packet gets exactly where it needs to go. Okay, so before the trip even starts, our data has to get packed up. This process is called encapsulation, and it's kind of like preparing a package for international shipping. First, up at the top layers, the application and presentation layers, your data is formatted and, most importantly, encrypted for security. Then, the transport layer adds its own label to make sure all the packets arrive and get put back in the right order. After that, the network layer adds the big destination IP address, the where in the world is this going part. And finally, the data link layer adds the local address for just the very next stop before the physical layer turns the whole thing into electrical signals or light pulses. Each step adds a new protective wrapper, getting it ready for the open road.
But just like any big journey, this one has its share of dangers. That digital road can be a risky place. And at pretty much every layer of the OSI model, there are specific threats just waiting to intercept, steal, or mess with our little data packet.
The first danger we'll talk about strikes at the very top, at the application layer. This is the layer that you, the user, actually interact with, your email, your web browser. Phishing attacks don't target the technology, they target you, trying to trick you into handing over your information before a data packet is even created. What makes phishing so darn effective is that it's all about psychology. It's not about writing complicated code, it's about exploiting human trust. Our source material actually tells the story of a user named Anne who fell for one of these, and it's a powerful reminder of how devastating this simple, high-level attack can be. Now, another huge threat also at the application layer is called an SQL injection. But instead of targeting you, this attack goes after the application on the server. A hacker can slip malicious code into something as simple as a search bar or a login form, and if that application isn't built securely, it can be tricked into giving the hacker the keys to the entire database. So let's move down the stack a bit. Here we run into DDoS attacks. This is just a brute force assault. Hackers use an army of infected computers to just bombard a server with so much junk traffic that it gets totally overwhelmed. It's like creating a massive, instant traffic jam on the digital highway, specifically clogging up the network and transport layers so legitimate packets, like yours, can't get through. You know, sometimes the danger is much closer to home. At the data link layer, which handles your immediate local network, a hacker sitting in the same coffee shop on the same public Wi-Fi can digitally place themselves right between your device and the router. They become a secret eavesdropper, intercepting and reading your data as it goes by. So that all sounds pretty scary, doesn't it? But here's the good news. For every threat, there is a defense. Our data packet doesn't travel alone. It has guardians protecting it at each and every layer of its journey. The most fundamental guardian of them all is encryption. This happens way up at the presentation layer, before your packet even leaves your computer. Your login info, your messages, it all gets scrambled into unreadable code. So even if that man-in-the-middle attacker does manage to intercept your packet, all they're going to get is a bunch of useless gibberish.
So what about protecting against those application layer attacks, like SQL injection? Well, servers use a special kind of bodyguard called a Web Application Firewall, or WAF. Think of it as a highly trained security guard for the website itself.
It inspects every single incoming request at layer 7 and is smart enough to spot and block malicious code before it can ever do any damage.
Then there's the more general firewall. This one acts as a broader gatekeeper for the whole network, usually operating at the network and transport layers. It checks packets based on their source and destination addresses, and it's programmed to drop anything that looks suspicious or is part of a massive flood, like a DDoS attack.
And these firewalls come in two main flavors. You've got hardware firewalls, which are physical devices. Your home router is a great example, that protect your entire network. And then you have software firewalls, which are programs installed on your computer, like the one that's already built into your operating system, protecting just that one machine. The most secure setups, well, they use both.
And to protect yourself in that coffee shop, your best bet is a VPN. A virtual private network creates a secure, encrypted tunnel for your internet traffic that starts right from your device. This basically makes your data packet completely invisible to anyone snooping on the local network. It totally neutralizes that man-in-the-middle threat.
So we've seen the whole journey, we've seen the dangers, and we've met the digital guardians. But all of this incredible technology relies on one final, absolutely critical component to really work effectively.
And that component is you. All this amazing technology is only part of the solution. These systems are designed to protect your data, but the ultimate responsibility for starting a secure journey, well, that begins with your actions. So what can you actually do? This checklist, which comes straight from our source material, lays it all out. Use strong, unique passwords that are tough to guess. Be suspicious of emails you weren't expecting. That's how you avoid phishing. Use a VPN on public Wi-Fi to guard against eavesdroppers. Keep your software updated so you have the latest security patches. And just don't click on random sketchy links. These really simple habits make a massive difference.
Every time you click, every time you search, every message you send, you're launching another data packet on this incredible, complex journey. It's a constant flow of your personal information, protected by all these layers of technology. So the question I'll leave you with is this: knowing the path and the perils, are your habits the strongest link in your security chain, or are they the weakest?